Okay, we're going to look at lesson 1. It's all about deductive reasoning, and we're going to look at some logic. And so you've got some notes that have to do with inductive reasoning and deductive reasoning. So I'm not going to go through those definitions right now, but what we're going to go through is the process of syllogisms. It's a study of logic where we look at a major premise, a minor premise, and we get a conclusion. This whole process is called an argument. And what we're going to check for is validity, not whether it is true or false. Okay, we're going to look at validity. So I'm going to put this book here, and we're going to look at a few things. All men are mortal. Aristotle is a man. Therefore, Aristotle is mortal. Now this has a logical sequence. You have your major premise, you have your minor premise, and you have a conclusion. Alright, so now let's look at what we would do in geometry. The sum of the exterior angles of a convex polygon is 360 degrees. Triangle ABC is a convex polygon. The sum of the exterior angles of triangle ABC is 360. So it says that every member has to be a polygon. That's what the major says. The minor identifies it that the triangle is a convex polygon, and so then if it is a convex, it has to have all the properties of a convex polygon. Let's see if we can get one that is valid but not necessarily true. So all frogs have green legs. Henry is a frog. Or all frogs are green. Henry is a frog, so Henry is green. Okay, it's valid. Doesn't mean it's always true, but it's valid. If it rains, I will go to town. It did not rain. I did not go to town. That is also a valid argument. Now let's look at this one. All normal dogs have 4 legs. That dog has 4 legs. Now notice, this is your major. All normal dogs have 4 legs. So it should have said that dog is normal. And then you could have concluded the dog then has 4 legs. But you can't do it this other way. So that's why this argument is invalid. Alright, let's try this next one. All boys are good. That child is a good child. That child is a boy. It's not valid. All boys are good. This should have said that child is a boy. Therefore, that child is good. However, it doesn't do it in that format, so it's not valid. Here's a typical one. All chickens have 3 legs. So there's your major. Henny Penny is a chicken, so we're looking here. So our conclusion should be that Henny Penny then has 3 legs. So you see the pattern? This states that the characteristic of something. So here we have chickens, and the characteristic is 3 legs. Then we tell you in the minor premise what this object is. It is a chicken, so therefore it has to have 3 legs. Not a true argument, but it is valid. Okay, this chart's going to be real important when it comes to logic. You have your conditional, if then, if P, then Q. Your contrapositive, that means not Q, then not P. Your converse, where you switch the Q and the P. And then your inverse, not P, not Q. And if all these are true, then you have an if and only if example. Alright, so for example, if we have a rabbit, it is fast. If it is not fast, then it's not a rabbit. If it's fast, then it's a rabbit. If it's not a rabbit, then it's not fast. Now these obviously aren't going to necessarily be true. Let me give you an example of another one. Alright, so let's look at this case here. If you have a square, then it's a quadrilateral. That's true, because quadrilateral means 4 sides. If it's not a quadrilateral, you don't have a square. That's also true, because a square has to have 4 sides by definition. If you have a quadrilateral, it's a square. That's not necessarily true. You could have a rectangle or a rhombus. If it's not a square, then it's not a rectangle. Or not a quadrilateral. That's not true also, because you could have a rectangle and it's still a quadrilateral. So let's look at an if and only if statement where everything is true. All right, if sides have equal lengths, then the angles have equal measures. All right, that's true. Now the contrapositive says I take not this one, then I would have not this one. So if the angles do not have equal measures, then the sides do not have equal lengths. That's true. Now the converse would mean that I would just flip these two. So if angles have equal measures, then the sides have equal length. That is true. And the inverse would be where I would flip these and make these a knot. Sides do not have equal lengths, angles do not have equal measures. And that's what we call an if and only if statement. Now you're done with lesson 1.